Today on Capechi's Corner, we're going to look at proofs involving parallelograms. In our first proof, we have parallelogram ABCD, which is our big figure there. And then we have angle 1 is congruent to angle 2. We're trying to prove that segment AX here is congruent to segment YC. Now we always want to work backwards a little bit to figure out how I can get there. Well, I have two triangles on the outside of that parallelogram, and if I can prove that those two triangles are congruent, then I can say that segment AX is congruent to segment YC from CPCTC. So let's see if we can do that. We have our given, angle 1 is congruent to angle 2, so I'm going to mark that. And then we know that ABCD is a parallelogram, so we need to think of all the properties of parallelograms that we know about. One thing we do know, that opposite sides are congruent, so I have segment BA is congruent to segment CD, and that is because that opposite sides of a parallelogram are congruent. I'm going to mark my diagram. Then we also know about parallelograms that opposite angles are congruent. So I can say angle A is congruent to angle C, and that is because opposite angles of a parallelogram are congruent. And I'll mark my diagram as well. So I have angle A is congruent to angle C. Now, if you notice, we were trying to get these triangles on the outside congruent, and we can show that from angle side angle. So that's going to be my next step in my proof. I can say that triangle BAX is congruent to triangle DCY, and that is because of angle side angle postulate. And my last step in my proof is segment AX is congruent to YC, and we can say that because of CPCTC. In our next proof, we're given two parallelograms are in our figure, as well as angle 1 is congruent to angle 2, and we're trying to prove that this triangle here, triangle JHI, is congruent to our bottom triangle here, triangle GEF. So let's look what we have. Our first step, we have our given, so let's mark that angle 1 is congruent to angle 2, so it's one piece of our triangle. Now we know that we have parallelogram EFIH. That's kind of marked that. It's a little bit tough to see. So I'm talking about EFIH, and that's this big one right here. Now again, my focus is on my triangles at the bottom, so I need to figure out what I can use to get those triangles congruent. So I can say segment HI is congruent to segment EF. Now I picked those segments because they're both parts of the triangles that I'm trying to get, and they're both part of the parallelogram I just mentioned. So that I can say that because opposite sides of a parallelogram are congruent, and I'll mark that. So this piece right here is congruent to this piece right here. Now I just need one more piece to prove that my triangles are congruent because I have an angle and a side. So let's see what we can do next. Now I'm going to mention my other parallelogram here to see how that helps me. I know I have parallelogram EGJH, and that's given. And in this case, I'm also going to mark it because, like I said, this diagram is a little busy. So I have EGJH. So I'm actually talking about this parallelogram right there. Now, when I color that, it's a little easier for me to see. And I do notice again that I can use opposite sides. So I can say segment JH is congruent to segment GE, and that is going to be, for the same reason I used before, opposite sides of a parallelogram are congruent. And I'll mark those as well. So this piece right here is congruent to this piece. And now I notice I do have congruent triangles, so I can state my last step. I can say triangle JHI is congruent to triangle GEF, and I have proven that using side angle side postulate. Our last proof for today is a little challenging just because the diagram is very involved. I'm given that I have a parallelogram WXYZ, and I know that segment PY is congruent to segment WQ, and I'm trying to prove that segment BZ is parallel to segment XQ. Now again, I always like working backwards when working with proofs. If I'm trying to prove that PZ right here is parallel to XQ, if I can say 3 and 4 are congruent, then I can say that they're alternate interior angles, and therefore I can prove that those lines are parallel. So that's really going to be my goal. Now, how do I get to 3 and 4 being congruent? Now, again, I notice that I have a triangle here and a triangle here. So if I can prove that those two triangles are congruent, I can say 3 and 4 are congruent because of CP/CTC. So now my new goal is to prove that those triangles are congruent. So let's start with my given statement. I have PY is congruent to WQ. Now that's a little tough to see because they're overlapping. So it's this piece right here is congruent to this piece right here. So we do kind of have a weird sort of overlap. I know that I have a parallelogram, so I need to figure out what properties I can use. Now again, focusing on that triangle. So I can say that segment WX is congruent to segment ZY, and that is because of opposite sides of a parallelogram are congruent. I'll mark my diagram, so I have this piece is congruent to this piece. Now, I can also say, I know that the lines are parallel since it's a parallelogram, and then I can say 1 and 2 are alternate interior angles. So I need to get to that point. I can't say that 1 and 2 are alternate interior angles until I say that the lines are parallel. So it's going to be my next step. I'm going to say that WX, segment WX, is parallel to segment ZY, and that is because it's a definition of a parallelogram. That's what it tells us. The definition of parallelogram tells us that opposite sides are parallel. Once I say that, then I can say that angle 1 is congruent to angle 2. And that is because if two lines are cut by a transversal, then alternate interior angles are congruent. And I'll mark my diagram. Angle 1 is congruent to angle 2. Now I have congruency, so I can say triangle WXQ is congruent to triangle YZP, and that is because of side angle side postulate. Now I can say that angle 3 is congruent to angle 4 because of CP/CTC, and then I'm ready for my last step. I know that these lines are parallel. Segment PZ is parallel to segment XQ, and that is because if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel.